we are talking today about integrating BIM with GIS, case study of 250 square kilometer reality model project. My name is Abdallah Hazem, product analyst at Khatib Alami company, who lead technically the project, and my colleague Robert, manager in professional services at Khatib Alami. We want to share with you proudly that this project could won Reality Model Award in Infrastructure 2020 Awards. Our agenda today: first, Day overview. Second, our project, why and what. Third, project changes and solution. Fourth, project's outcome. Five, adding value and innovation. Khatib Alami overview. Who we are. Khatib Alami are an innovator that we design, manage, and supervise engineering projects. Khatib Alami, in a figure, we have more than 53 years of experience, around 6,000 employees, and project master experience. We ranked number 46 in the top 225 international design firms. What makes one dynamic organization unique? Because we have multiple departments. So we cooperate together, all subject matter experts, to produce one and only one outcomes, and with the best quality and best projects. How? By cooperating between architecture, planning, infrastructure, program management, and geospatial service integration, which I belong to this department. Our project. What is the project goal? Model classified with hard topography area. Geo-analysis aim to enhance decision making in predicting area efficiently by climate change and enabling margining. Second, enhancing security and response to alert. Third, to discovering security route and alternative passes in case of emergency, and discovering accessibility to red zones area in optimistic way. Project objective. What? To build a reality model and digital twin out of drone images for an area of 25 square kilometers to produce LOD3 for 43,000 building of GSD 10 centimeter, and we will discuss what is GSD and what is LOD3 after a while, and accuracy XYZ less than 20 centimeter. Second, performing geo-analysis application on the top of reality model. What is the project size? Around 330,000 images of size around 8,000 gigapixel and around 43,000 building to be textured and vectorized. Project vision or project aim. K&A aim to make this project a role model for similar 3D modeling service in the region. K&A with Bentley activated the contact capture license to build a reality model and married with Esri ArcGIS to produce digital twin application. What is the project challenges and what is the solution? Duration. The project had to be delivered within 90 days. 14 days flying, rest days for producing the reality model, and complete vectorization for large area, 250 square kilometer. GSD was 4 to 6 centimeter and absolute accuracy in 5 centimeter. And we will talk about absolute accuracy and what is absolute accuracy and relative accuracy in next slide. Processing. Large size production within 330,000 images for size around 8,000 gigapixels, achieved in 114 gigapixel per day. Resourcing. To complete vectorization challenges and produce LOD3 with building texturing for established for 43,000 building. Topography. Topography and weather was challenged because we have mountains and wadi close to each other. So in same mission, we could have wadi and mountain. The topology is hard and the weather is ups and downs. Publishing data. Publish large size model on web, overlay 2D data to utilities, POI, roads, and processing geo-analysis application. We will talk here about some terminology to be in the same base. What is GSD? GSD, or ground simple distance, is distance between center of 2 pixels measured on the ground. The image on the left has a GSD of 5 centimeter and the image on the right has GSD of 30 centimeter. So it's kind of resolution for the reality model. For example, a GSD of 5 centimeter means 1 pixel in image represent 5 linear centimeter on the ground. The same pixel will cover 25 square centimeter, 5 multiplied 5 centimeter. Ground simple distance is affected by the height you fly. By height you fly at, and the camera specification. A lower height with the same camera means lower ground simple distance and more details out and more size. However, flying lower means taking more time and batteries to capture the same image. Now we will discussing the accuracy. It's important to distinguish language between relative and absolute accuracy. Relative accuracy is accuracy comparing feature within reconstruction. For example, if a model of a building shows window 2 meters apart and it is the same distance as on the actual building, the model has high relative accuracy. Absolute accuracy is accuracy of reconstruction in relation to its true position on the planet. If the same model of the building is not in the correct place on the base map, it has a lower absolute accuracy even if it has a higher relative accuracy. And the picture shows the building has a high relative accuracy, but it's on the road, and this means it's in wrong position and has low absolute accuracy. We can expect the relative accuracy to be within 1 to 3 times the ground sampling distance. The absolute accuracy of a correctly reconstruction project is 1 to 2 GSD horizontal, X and Y, and 1 to 3 GSD vertical, is. And one of another terminology we must discuss is ground control point, GCP. Are points to know coordinates in the area of interest. Their coordinates have been mean with traditional surveying method for or have been obtained from other sources, LiDAR, old maps of the area, web map service. They are not required for processing a project with, but they increase significantly the absolute accuracy of the project. GSP can also be used as checkpoint to verify the accuracy of the results. Ground sample distance of the images, the GSP should be visible in the images. The GSP photogrammetry target should have about 5 to 10 times the dimension of GSD. For example, if the GSD is 10 centimeter, the GSP accuracy should not be below 1 centimeter, since they couldn't be marked in the image with such accuracy. Project challenges in a couple of words: duration, quality, limited timing, weather, and topology challenges. So our workflow, we can divide it into 3 steps. First, drone flying and data capture. We preparing this stage the infrastructure and hardware and selecting hardware and software and planning flight mission, placing down the control point. In the second stage, building reality model and checking accuracy and checking flight accuracy. Aerial triangulation, we can make in aerial triangulation, checking accuracy of type point and reconstruction. And the third stage is digital twin application. We publish as scene service, overlay 2D data with Z value, simulation, vectorization, and smart attribute and spatial analysis. This is a sample of spatial in the first stage, sample of hardware and software and the planning mission and this kind of flying and capturing. This is a drone and how it move in passes. Third, the planning mission and marking ground control point. Project solution. How we achieve these challenges? First, UAV drone flying and capture. Second, 3D modeling using Bentley Contact Capture Center. Why? Because it produces large area, fast, and able to produce different formatting such as KML, high DSM, and low DSM, I3S for GIS integration. Third, tools like barcode, tiling concept, and the algorithm of reconstruction different images with different brightness and angles. Fourth, digital twin, geo-enabled reality model. We can achieve this by using Esri ArcGIS Pro 2.5 to develop the vectorization model and publish the 3D reality model into web portal for ArcGIS version 10.7. The vectorization model is based on semantic segmentation to classify the DSM to produce the LOD3, and we will talk about it in details in the part of innovation of this project. Fifth, develop 3D tool for scene service in portal for ArcGIS to share reality model among internal stakeholders. Let us talk in details about UAV drones advantage that we use it as a fixed wing. Why we use fixed wing drones? First, for significant range. Fixed wing aircraft can fly long on a signal pattern circle. It makes them ideal for mapping very large or linear areas because they don't have to fly home for a battery replacement as often during a signal mission. Second, greater stability. The airframe design of fixed wing aircraft gives them larger stability in high wind, and this we suffer of this in Oman because there is some days is foggy or have heavy wind, and this is important for flying in environment where higher wind are expecting or fluent, and this is our phenomenon. Third, the power loss. Suffer recovery from motor power loss. If a fixed wing aircraft loses motor power, in theory, it is able to glide down to safety. Linear flight advantage. Fixed wing aircraft are ideal for long distance flights, such as pipeline. However, this capability is currently limited to line of signal LOS. Second, how can we solve the large number of GSP? We have in this project around 600 GSP points. How can we recognize each point in this large area? We have area 250 square kilometer. This project, we must search for about 500, 600 points in this large area. How can we do it? We produce GSP as a barcode instead of regular shape. The higher figure is the regular shape of GSP that we must get it from the image, and the second one is barcode. The advantage of this choice, it context capture can easily recognize it after area triangulation. Second, the intersect it increases the absolute accuracy because it used as a tie point as well as. Third, decrease the human error in relative accuracy because we can use it as checkpoint. Disadvantage, the size of the target are much bigger than normal targets because this edge length is equal GSD multiplied 35. Our outcomes in this project is one reality model in KML format and I3S format, one 3D reality model in I3S format with GSD 2 to 6 centimeter and accuracy 5 centimeter, more than what we must achieve. One isometric photo area imagery, one complete DSM with accuracy 4 to 6 centimeter, 3D application with geo analysis advanced tools. And here the outcomes that we get. You can see the grades and the high relative accuracy and absolute accuracy. What the innovation that we could do it in this project? First, we marrying Bentley outcomes and ArcGIS outcomes by optimizing the vectorization and reduce building height and its details because of accuracy of outcomes of Bentley and the advanced classification and deep learning in ArcGIS. We could reduce the vectorization period from 3 months to 30 days and reduce number of resources from 9 to 2. And reduce the cost around 198,000 US dollar. We developed two processes to automate the vectorization. First, we merge the constructed raster images into one DSM and one isometric imagery for the whole area. We achieve this by an innovating tool that cleans the tiles and collect all geo-reference images from different styles and make one raster mosaic. We make the raster mosaic multiple layering. This guarantees the raster to be easy published on the web. The automation was developed as easy as it can be used by the client in the future. Just a click. Second, we have vectorized around 43,000 buildings with LOD3 by 1. We generated DSM automatically from the images. 2. We built a tool to classify the DSM into two clusters based on change of building height and area. The tool divided the whole project on small tiles to minimize the errors in the classification. Third, we have run the semantic segmentation for the DSM, classifying it using joint natural break classification. In other words, the method seeks to reduce the variance within the same class and maximize the variance between classes. Fourth, we use other methods such as clipping, checking accuracy, and extracting ground roof level for each building. And finally, we split the roof level from the ground level in order to get building height and then extrude it. The result is 3D vector to geo-reference model. The ICS and vector model are overlapped on same level. So when anyone click on the building, the attribute into the info will appear and it can be edited. We overlay roads, point of interest, and utilities with the reality model for better planning and analysis for infrastructure in case of tourism and security attacks. We use the data to develop dashboard for decision makers to understand their areas and decide best option in urban development and national security. We manage the natural resources in the desert area and discover the alternative resources and facilities. We develop models for alternative accessibility in case of emergency. And this is some tools of the digital twin. We enable it to decision maker as align 2D plot area on the top of 3D building and published on the web, or light of sign and sketching, and tool to slice the building. These tools all we put in the dashboard and the web application to be easy to manage with the tool, with the reality model. I would like to thank you for listening to me, and I hope this presentation was up to your expectation. Thank you and have a good day.